Find the pointer points where the tangent line for x squared over 16 plus y squared over 9 equals 1 is A, horizontal, and B, vertical. The horizontal tangent line has a slope of 0, and the vertical tangent line has a slope that will have 0 in the denominator or go to infinity. So to determine where this occurs, we need to find the slope of the tangent line. That, of course, is the derivative. We have an implicit equation here. X squared over 16 plus y squared over 9 equals to 1. So to find the derivative, we will have to take it implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. The first term is a power rule, and the power comes down and you subtract 1 from the power. The 1 over 16, or the 16 in the denominator, is a constant. It just comes along with the derivative. Plus the second term, which is also bring down the power, subtract 1 from it, the 1/9 comes along. But because we are taking the derivative of a y term, we have to multiply by the derivative of the inside, which is a y prime, to complete the chain rule. Every time we take the derivative of a y term, we get a y prime multiplying it. On the right side, the derivative of 1 is a 0. We now want to solve for y prime by isolating the y prime term, so we have 2y over 9 y prime equals to negative 2x over 16. And we can solve for y prime by multiplying both sides by a 9 and dividing both sides by a 2y. So we'll have a 9 over 2y. It ends up being multiplied by the reciprocal of the coefficient on the left. The 2's can cancel, and we have negative 9x over 16y. We now want to find the points where we have the horizontal and vertical tangent lines. So for part A, to have a horizontal tangent line, we want our slope, which is our derivative, to be a 0. To be a 0, we want the numerator to equal 0. Down here, our numerator is negative 9x. We want that to equal 0. So negative 9x equals 0. We can divide both sides by negative 9, and apparently x needs to be a 0. Now that's simply the x-coordinate. We will also need to find the corresponding y-coordinate or coordinates by plugging this result back into the original relation where you're on that curve. So we will have 0 squared over 16 plus y squared over 9 equals to 1. Well, 0 squared is 0, divided by 16 is still 0, so that will give us y squared over 9 equals to 1. Multiply both sides by 9, and we get y squared equals to 9, and we can take the square root of both sides, or subtract it over and factor. It'll work out either way. Just don't forget the plus or minus. So y can be positive 3, and y can be negative 3. We already have our x-coordinate of 0 found up here, and here's the corresponding y-coordinates. Apparently we have 2 points where this occurs at. So we have an x-coordinate of 0 with a y-coordinate of 3, and we have an x-coordinate of 0 with a y-coordinate of negative 3. There's the 2 locations where the tangent line will be horizontal. To find where it's vertical, we want the slope, which is y prime, to go to infinity. And it can be positive or negative infinity. This occurs by the denominator equaling 0. If we look at our derivative, y prime, we want this denominator to equal 0. 16y we want to set equal to 0. So 16y equals 0. We can divide both sides by 16 and y equals 0. We need the corresponding x-coordinates. Again, this result here will plug into the equation because we are on that curve. And so we have x squared over 16 plus 0 squared over 9 equals to 1. 0 squared is 0 over 9, and 0 over any non-zero number is always equal to 0. So we can ignore that term. It's equal to 0. We have this equal to 1. We can multiply both sides by 16. And we can now take the square root of both sides. Don't forget the plus or minus, so we will have a positive 4 or a negative 4. These are our x-coordinates that get paired off with the y-coordinate that we already know to be a 0. So we have a 4, 0, and a negative 4, 0. And there's the 2 points where the tangent line will be vertical.